In the name of God. Hello, dear students. My name is Masood. I'm a physics teacher. I'm going to welcome you to Fairfly's website. We are here in this website to explain physics curriculum, grade 11. So far, I explained some subjects has to do with chapter 1. Some subjects have to do with chapter 1. Right now, we are going to discuss, let's say, one more subject, which is distance. Right? So what's the distance? More or less, any person is familiar with distance. Any person, let's say, heard the distance before, even if the person is illiterate person, right? But we are going to, in this lesson, we are going to discuss the distance scientifically, physically, and accurately, right? Let me read the definition of distance for you. It's the total length of the path followed by a moving particle. Total length of the path followed by a moving object. This is called distance. Right. We have two notes here regarding the distance. Distance has no direction. So, distance is a physical quantity that has no direction. This is the first note. The second note, distance might not be a straight line. Distance may not be a straight line. Sometimes distance is a straight line, sometimes not. It doesn't matter, right? So, for example, this car circles the square. There's a blue car. This blue car tends to circle the square. That's why whenever you measure the path followed by a car, this is called distance, right? How many meters, for example, this car, let's say, traveled whenever it turns this square. This is called distance. For example, you say, teacher, 10 meters, 20 meters. So this number is called distance, and has no direction. Distance has no direction. So direction does not matter in distance. Distance does not require the direction. Right. This is about the distance. Uh, and then I told you, let's see, let me tell you this one, for example, another. Distance might not be a straight line. Sometimes distance is a straight line, no problem. Whenever you follow a straight line, you travel distance. Whenever you turn for example, circular track, this is distance. So it doesn't matter whether the path is a straight line or curved line or zigzag or circular track. It doesn't matter, right? The entire length is called distance. Let's move on to another subject, which is called displacement. Right, displacement, let's say, have three definitions in our textbook. Let me read the definitions for you. Definitions for displacement. Number one, the smallest directional distance from the starting point to the ending point of a motion. The smallest directional. So displacement, let's say, has a direction. Displacement needs a direction, right? It requires a direction. That's why it says the smallest directional distance from the starting point to the ending point to the end point of a motion. This is the first one. And let's say in our textbook mentioned smallest. Smallest means we have a shortcut, right? Smallest directional distance from the starting point to the ending point of a motion, and it should be a straight line. Displacement must be a straight line. Right. Number two, the length of the straight line. You see, it's more accurate than the previous let's say definition, because it mentions the path a straight line is dedicated for displacement. So if the path is not straight and the moving object follows this path, so the path is not actually the path uh, actually uh, whenever you measure the path, it doesn't actually it doesn't consider displacement. You can measure the displacement for a moving object along a curved path by what? By drawing a straight line from a starting point to the ending point, no problem. But you cannot, let's say, measure the length of the curved path, I mean. Right. So the length of the straight line drawn from an object's initial position to its final position. The third one, the difference between the object's final and initial coordinates. The third definition is a little bit mathematical. It's a mathematical definition. The difference between the object's final and initial coordinates. I'll explain it for you. Actually, it's mathematical, but let's say the previous definitions, both previous definitions are more physical than the third one. But all of these definitions are required for you, let's say, to memorize. I compared the distance and displacement in a table. Let's read the table together, and we want to discuss the table, understand these subjects, let's say better. Distance versus displacement. On the left side, we have distance. On the right side, we have displacement. Distance, number one, sum of the tracks in which motion occurs. Sum of the tracks, right, means it's the summation, right? Summation of the tracks in which motion occurs. What is about displacement? It's opposite to the distance. Subtraction, then subtraction or difference. Subtraction of the tracks in which motion occurs. That's why I told you this definition is mathematical, right? Subtraction of the tracks in which motion occurs. This is about the displacement. The second difference, distance has no direction. It's not directional quantity. Number two, for displacement, has direction. So it's the directional quantity. Displacement is a directional quantity. It needs direction. So direction matters in displacement. Number three, for distance, might not be a straight line. Maybe it's a straight line, maybe not. It doesn't matter. So path does not matter in distance. Just measure the entire length of the path and you can calculate the distance. But about the displacement, number three, displacement must be a straight line. It must be a straight line, right? Even if you have a circular track or you have a curved path, it doesn't matter. You have to draw a straight line from a starting point to the ending point. That's why we say, let's say, it's the smallest directional path. Smallest directional path. That's why I told you it's a shortcut, followed by the object from a starting point to the ending point on a straight line. Right. The fourth one for the distance actually is not the difference. This is the comparison. It's not the difference because it's common. Number four is not the. It's common between distance and displacement. Distance expressed in millimeters, centimeters, meters, and kilometers. They are units of distance, but which one is valid? Let me mention this one. Meter is valid in SI. In SI, I mean System International for Units. Meters, actually, meter is valid for distance. But there are probabilities, actually. Probabilities, but let's say, about for other units. Maybe the question let's say, tells you gives you a distance in kilometers, in centimeters, in millimeters. It's okay. About the same point, number 4, for displacement, displacement expressed in millimeters, centimeters, meters, and kilometers. And which one is valid in SI for displacement? Meter. Meter is valid in SI. Right. We want to keep going the subject displacement. We want to get more information about the subject. We have. I'm gonna let's say discuss properties of displacement with you. So displacement has some properties. 3 properties of displacement are mentioned in our textbook. Let's discuss them together. Let me read the first property. Displacement is a change in position. Is a change in position. That's the first property. Number 2, displacement is not always equal to the distance traveled. Right now, it's just a title. After that, in next lessons, I'll elaborate it for you, and I'll give examples for you for better understanding the subject. Number 3, the third displacement property. Displacement can be positive or negative. Displacement can be positive or negative. That's why it's a directional quantity. Any directional quantity has actually direction, whether the direction is positive or negative. I'll explain for you in, let's say, in next lessons. Number 1, actually about the first property, displacement is a change in position. It's mentioned here. Displacement is a change in position. Mathematically, we can say delta x is equal to xf minus xi. Delta x itself is change in position because delta in science, in physics, in mathematics, in chemistry, delta in science in general means change. Delta x means change in x, and delta x together means it's a sign of, let's say, displacement. You can use delta x for distance as well. Right. So delta x is change in position or displacement. Keep in mind that we denote displacement as delta x from now. xf, maybe you say, teacher, what do you mean by xf? xf is the final position. Final position means xf. X sub f actually, xi or x sub I is the initial position. xi, initial position. So delta x means displacement is equal to final position minus negative position. You have to subtract the first coordinate from the last coordinate in order to find the displacement. That's why I told you this is called, that's why I told you the third definition that I read it for you. Let's say I said this is a mathematical definition. It's a difference between 2 coordinates, difference between 2 positions, difference between the final coordinate and initial coordinate, like this. So this is called, this is the first property. Right? Let's move on to another, and the second property, I'm gonna, let's say, finish this lesson here. I'm gonna leave the second property for you for the next lesson. Thank you so much for watching this video, and bye for now.